Hey guys, welcome. That's how I start all my geometry videos. So you might not be here today, so I made a video and in front of a live audience of 7 kids. So here we are. So key characteristics of a quadratic function. The standard form of a quadratic function is f of x, which f of x is just the same as y. If I'm going too fast, you can pause the video and write this down. But it says f of x is the same as y. We get ax squared plus bx plus c. And when graphed, a quadratic function creates a u-shaped curve called a parabola, which looks something like this or this. We modeled these when passing the hacky sack in class, and with the will it go in the hoop activity we did in Desmos. We've been dealing with things that look like this with factoring for quite a few weeks. I know we took a little break for doing radicals, but we would call this the quadratic. So we're going to go over some key characteristics. Our first one is the vertex. So if you draw a little parabola over here and a little parabola right here, this is showing us the vertex would be these points right here. And the vertex is the highest or lowest point on a parabola. Okay, so the highest or lowest point on a parabola. And if you, sorry. If you have it up here, this would be called our maximum. If it's down here, this would be called our minimum. So we can actually find the coordinates of the vertex pretty easily using this formula of h equals negative b, and that b comes from this up here, over 2a. Okay? And just to let you know, what is this h? Like, what is Mr. Smith saying? What's this h? The h is the x value of the vertex. Okay, we can see that right here. There's my h. Okay? And then to get the k value, which is the y value of the vertex, which we'll talk in, we're going to plug the h value in for x into the original equation. Again, that k right here is the y value of the vertex. Okay, so we're going to do 2 little examples. Again, I see negative b over a, and I know where my a value, my b, and my c value are given my standard form of a quadratic. And let's go ahead and start. So I like to first identify my 3 values. So a is 1, b is 6, and c is 5. Again, that's the value in front of x squared, in front of x, and then by itself. Okay? This is super trippy because I'm looking at it on my screen, I'm looking at it here, and I can see it over here too, so it's like a lot going on right now. Anyway, so we're going to find my h value first. So h is equal to negative b, so negative my b value, which is 6, over 2 times my a value, which is 1. Okay? So negative 6 divided by 2 is going to become negative 3. So h is negative 3. All right, so we got that piece. Now we need to plug the h value in for x into the original equation. So here's my original equation. And instead of x, I'm going to put parentheses. And I'm going to plug in the h value of negative 3. So I got negative 3 in for the x value. Negative 3 squared is going to be positive 9. 6 times negative 3 is a negative 18, and then plus 5. Okay? When you combine all that, you get k equals negative 4. And so my vertex, my final answer for my vertex is -3, 4. Sorry, -3, -4. And that is my answer. Yay, Mr. Smith, you're so good at math. I know. Quiet down, big crowd. So, yeah. Okay, let's move on to the next problem. Now on to number 2. Okay, here we go. I'm going to write my A, B, and C value. I'm going to go a little faster this time. A is -1, B is -4, and C is 12. I want to find my H value. Again, my H value is equal to -B over 2A. So -B, so that's a negative in parentheses. My B value, which is also a -4. So I do see that there's 2 negatives there. And then times 2 times my A value of -1. -4 makes a +4. 2 times -1 is a -2. So my H value ends up being 4 divided by -2, which gives me -2. Okay? Now I plug it back into my original equation, so it's -x² minus 4 plus 12. Okay? So instead of x, we're going to plug in -2 here. Now -2 squared is 4, but then there's a negative out front, so it's a -4. -4 and -2 make a +8, and we get a +12. You combine like terms, or sorry, not combine like terms, you add all of this up, you should get k, sorry, I do that in the right color format, k equals 16. And then for my hk, which is my vertex right here, we see it's h comma k, so that's going to be -2 comma 16. Yay, Mr. Smith, you're the best. Oh my gosh, you're hilarious. That one was real. That one was real, guys. You're the best. That reminds me of Moana. When Moana, you're the best. Okay, this is actually going in the video, so I got to keep moving. Here we go. Otherwise, the people in the video are going to be like, oh my gosh, Mr. Smith, just do the math and stop talking about randomness. Okay. Here we go. Axis of symmetry. So we just found, we can find the vertex. Again, the vertex is our maximum or minimum position. Now we can find the axis of symmetry, which I tried to get my class to be situated in a symmetric pattern so that I could make one of the students the axis of symmetry, but of course one of my students decided not to sit in the seat of axis of symmetry. I won't name who that is, but let's move on. Anyways, the axis of symmetry is a vertical, which is cool, line that divides a parabola into 2 equal parts that are reflective of each other about the line of symmetry. The axis of symmetry is an equation of a vertical line. All right, so how do we find the equation for the axis of symmetry? Well, it's going to look very familiar. X equals -b over 2a. Now, the -b over 2a is the same thing we saw up here. And that's because the axis of symmetry actually will always go through the vertex. So the x value of the vertex is actually, if we set that equal to x, that will give me the right thing. So if you saw that and you're like, wait a second, that looks familiar, well, you weren't wrong. Okay? So let's write that note real quick. It is same as the h value of the vertex. And that's because the axis of symmetry will go through the vertex. Okay? So this one's actually a lot faster to solve. we don't really have any issues. Now, this equation right here looks a lot like equation from number 1. And so because it's the exact same equation as number 1, and it's the same as the h value, I just have to do x equals what I got up there, which is -3. So that one was super fast. And if you're like, Mr. Smith, where'd that come from? You're going to say work is from the h value in problem number 1. If you don't want to write that, you don't have to, but there's a big arrow showing it. That's where it came from, because we said it's same as the h value in the vertex. This one, we could do the same thing. Let's actually just show the work real quick, but it is from here as well. But we could just do x equals -b over 2a, which means x equals negative in parentheses 2 in parentheses. My b value right here is -4. My a value is -1. That makes it a +4 or -2. Sorry, over -2, which makes this -2. So x equals -2. But if you see, it was the x value from this one because it was the same equation. But that's my axis of symmetry. This is an x equals line. It's going vertical. Okay? So over here, last thing I want you to do is draw 2 little parabolas, just like you had on the vertex. Draw that vertex right there. The axis of symmetry is a line, usually dashed, that goes right through the middle of it. Okay? All right. Woo! Notes are done. Nice. Better not be a backside. Wait. There's a backside? No. Mr. Smith wouldn't do that. This video is already getting too long. Oh my god. Oh. There's totally a backside. Who could have foreseen this? Definitely not me. Oh man. Alright, you want to do the back now?
No.
Alright, cool. I don't care what you say. I don't fall to peer pressure. We're going to do it anyways. Here we go. The y-intercept. Here we go. Examples and x-intercept, and we're done. It looks really easy. The y-intercept is the point where the graph crosses the y-axis. Cool. That's why it's called intercept, meaning hit or attached to. To find the coordinates of the y-intercept, it's 0, y. Well, that's pretty easy. The way we get that is if we plug in 0 for x. So if you plug in 0 for x and solve for y. But when you plug in 0 for x, that does something very special for us. It just ends up becoming the c value, which is really cool. Okay? We'll say that later, but let's just try it. Y equals, instead of x, I'm going to leave little holes. I'm going to plug in 0, like I said. 0 squared is 0, plus 6 times 0 is 0, plus 5. Y equals 5. Cool. Do it again. Over here, we get y equals negative x squared minus 4 times x plus 12. But instead of x, we're going to plug in 0. Negative 0 squared, or 0 squared with a negative is 0. Negative 4 times 0 is 0. So we get y equals 12. Okay, so our y-intercept is always just 0, c, whatever my c value is. Okay, and we can write that right here if we have a little bit of space. Y-intercept will always be the c value. That's the most important part. It's going to be the c value. So do you really have to show that it plugs into 0? Nope. Don't have to do it. Okay. Moving on to x-intercepts, and then we're out of here. Okay. The x-intercept is a point where the graph crosses the x-axis. If y-intercept is where it crosses the y-axis, this is where it crosses the x-axis. Okay. X-intercepts are also known as roots. Sometimes we call them roots, not ginger root, but just roots. X-intercepts are also known as zeros. Not Mr. Smith. He's not a zero. Everyone doesn't like my jokes. And x-intercepts are also known as solutions. Okay, so roots, zeros, and solutions are my x-intercepts. A quadratic function can have 1, 2, or no solutions. Okay, that's based upon where my parabola is located. Okay? Okay. And then you can find the x-intercepts of a quadratic function by graphing, factoring the quadratic formula, computing the square or square roots. That's a lot of different things that we have not fully got to. So, let's take a look at the key points of a quadratic function. Here we go. All right. Step 1. When a is greater than 0, so see a is greater than 0, the parabola will open up. And the vertex will be a minimum. You can see this point right here is clearly the lowest point on this graph, right? Every other point is above it, so this is a minimum, and it's pointing up. But that right there is my vertex. And what is the vertex of this graph? Okay. Oh no, my battery's running low. I need to talk faster. Okay. So the vertex here is at, it looks like -3, -4. Okay. What's the axis of symmetry? Well, we know the axis of symmetry goes right through the middle of this, so it's going to go right through here. And it's the same as the h value. And the h value is that first one, so it's just x equals -3. The x-intercepts, I can see where it hits the x right there, 1 and 2. Those are my x-intercepts. So those are my Okay, so the vertex is -3, -4. The axis of symmetry is x equals -3. The x-intercepts are at -1 and -5. So that would be -1, 0 and -5, 0. The y-intercept is right up here. Okay, and the y-intercept is at 0, 5. What is the domain of the graph? Well, the graph will actually cover all the x values. As it goes up, it's slightly going outward. So it's going to hit -infinity to +infinity. And then the range, which is my y values, is going to go from -4 all the way up to infinity. So -4, it won't go, because that's the minimum, all the way to infinity and beyond. All right, let's do this last one, and then we are done. When a is less than 0, and we have here a is equal to -1 now, it's going to go down. We're going down. We're yelling timber. Okay. By the way, this should be a bracket. Thank you very much. Random student in the classroom. That's definitely not an adult. So, -4. Bracket. I even have that in my notes, and I just wrote a parenthesis. So, there we go. So a is less than 0, the parabola will go down, and the vertex will be a, well, if this is a minimum, this one would be a maximum. So there's our vertex right up there. This time it's a max. We're not going to get any higher than that for this parabola. And this vertex looks like it's at -2, 16. The axis of symmetry, again, is going to go right through that h value of -2, and it's a vertical line, so it's an x equals -2 line. The x-intercepts, I see them right here and right here. Okay, this time I'm just going to call them solutions. Okay. And this looks a lot like our, will go in the hoop parabola. So this would be like it's starting at the ground, going up in the air, and then coming back down. But these would be called solutions, and these appear to be at -6, 0, and I think it is 2, 0, if I'm not mistaken. The y-intercept of the graph is right here, which looks like it's pretty close to 12. So that'd be 0, 12, 0 on the x, 12 on the y. And then the domain of the graph. So again, it's going to go outward forever as it goes down. So my domain is -infinity to +infinity. And this time, instead of having a number at our lower end be a value like we had -4 and all the way up, we're actually going to have -infinity. It's going to go down forever the range, but then it's going to cap at the top end, which is our maximum of 16. And Mr. Smith should do what here? Bracket. Write a bracket there. Okay? All right. Woo! We made it. I'm gonna stop the video.